really far down the road, but basically having a robot that or a brain that has common sense. That's the goal.
Yeah.
Is having it actually have true common sense. Like make it sort of figure that stuff out on its own. That would be good.
Well, that's hard to do because you still, at least right now, you still have to set that rules the way that it thinks.
Right. So what if you start writing this?
Nope, it works out faster.
You set the base rules and then it just starts building on its own.
Right,
It's like the iRobot where they have the 3 rules, and then they go off those 3 rules and then they look at how
Sorry, man.
Do you mind going over that one?
I think it's hard,
I'm
but
working
it's possible.
through all the solutions.
Okay.
I'm trying my best. It's,
Okay, it's fine.
Today's been,
Hectic.
it's ranged from disastrous to borderline
It's just
suicide, so
not-
it's been a day.
Okay, I'm sorry.
No, it's alright. But I
Be a part
will
of that.
try to get to them, even if I have to stay here till midnight, I will get them all. Which I have a feeling I'll probably end up doing. What's that?
Dedication.
Something like that, or stupidity, one of the two.
Because you are not very far apart.
Yeah, I know, I realize. There's a lot of times, I'm here till 10 at night, I get here at like 7 in the morning.
When we get there, that'll be something we think about. I'm gonna have to back a little bit.
Oh, okay, just the little slide. Talk about.
That's the thing, that's when the mood and stuff, but how far can you really go? Because
This is perfect right here. Yeah.
Did you finally read the first?
Yeah, I read it. Oh, well, it happens.
you're like overloaded. And here's you got these sentences. He's not decustomized. You know what the next word.
This is actually quite nine. I use how impression when I write.
Once it gets low, it starts getting bold, like a little bit lighter, and then like rotating the pencil to make the edge like flat, and then take it out.
I got a whole year of 25 cents trying to just write.
Yeah.
Almost a second later. This is real.
Yeah, that was me every single class.
I think that's what I was like 25, like writing lighter.
These are my notes from the class, but only some of my classes.
constant.
Yes.
Yeah, no pressure.
I like showing off those classes. It's like the way he teaches is actually like really should do it like that. Did you ever take any course?
Okay guys, so I think what we have to do today, we had one problem that we didn't get to last time with multiple quantifiers, correct? So we're going to finish that up. And then I wanted to spend the rest of the time talking about universal mode exponents and then the tolons and then diagrams as well. And then also reviewing for our examination, which is going to be on Wednesday, okay? I may have posted this on Blackboard, I'm fairly certain I did, but just in case you guys didn't see it. I think I said that Wednesday's the exam, and then assignment number 3 is due the following Monday. Is that correct? Just to make sure. Okay. So assignment 3 will we do on Monday, whatever that date is. Who knows? I guess it would be 19 plus 7 is 26. So Monday, September 26. Okay. If you guys want to work on it beforehand, that's fine. Okay, because those types of problems will be on the examination, but I won't require you guys to submit it until then. Okay? All right, so any questions before we get started, guys? Okay. Yes, sir.
We're allowed to have a note card.
Yeah, I'll explain that when we go through a review for the examination. But in case I forget, remind me, so that way I'll let you know. Okay? All right, other questions, guys, before we get started? Okay. So last time, I'm pretty sure we went through, we did a couple multiple quantifiers, but we didn't get through all of them. So I want to finish up this part. And I know on your paper it says write it in a sentence and in a sentence, okay? So typo. So if you guys would change that to write each of the statements in a sentence and symbolically, so that way we get a flavor of making sure we can do those both. Okay? So the first one, let's just do that one. Let's do them symbolically first, and then we can go through and we can write out what they actually mean, I guess, in some sort of sentence. Okay? So somebody remind me, what's the process that I would utilize to take the negation of something like this? And you might have to go back and look through like that definition that we had prior, but it's sort of the same thing as what we would do if it's just like a singular, not a multiple quantifiers. So, does anyone remember like the process for that? So,
I believe correctly, you change your all flip for every into there exists,
Perfect.
and then replace the comma with such that, and then with the where there exists, you change that to every,
Perfect.
and then the such that to a comma.
And then what do we do with the last part of the predicate
Is it
there?
not Q?
You take the negation of that. Very nice. Guys, I think he said it very eloquently. Okay, you just basically flip your quantifiers, commas go to such that goes to comma, and you take the negation of the predicate at the end there. Okay, so let's say we were to write number 1 symbolically. Okay, we would say there exists x in I, comma goes to such that. The there exists goes to for all y in I, the such that goes to comma, and then all I'm going to do is just take the negation of that last part. Instead of xy in Q, xy not in Q. Okay. Xy not in Q. Okay, nice. We can do the exact same thing with the second one. Okay. So I'm just going to write this symbolically first, because that's the easy part, I think. Okay. Instead of there exists x in R, we can say for all x in R, instead of such that, comma. Okay. And then instead of for all, there exists y in Q, instead of comma, such that, and then instead of xy in Z, xy not in Z. Okay, so let me give you guys a second to copy that down. Okay, but that's easy, right, guys? If you saw that on your guys' examination, you guys know. Flip the quantifiers, flip the commas, and such that. That's easy stuff. Okay. All right. Now, what might be not as easy is being able to write those in sentences. Okay, and that's what we have to remember. What are the different sets and that sort of thing. And remember, we want to eliminate any variables as well. Okay, so we shouldn't be using like any x's, y's, or elements of and all that stuff. Okay, so let's just start with this guy here. Okay, so obviously this means that there exists. Okay, I already said that. So we can say there exists, and instead of x in I, okay, what can we say instead of x in I? Some irrational number, right, guys? So there exists some irrational number. Nice.
Would some have to be?
I'm sorry, not irrational. Oh yeah, it is irrational.
Some
Go ahead. So, would some
Some
have
have
to
to be a key word, or could you put like, there exists any rational?
That's correct. You could say some, any, at least one, something like that. Okay, so there exists some irrational number such that, obviously, for all, so there exists some irrational number such that for all what? For all other irrational numbers, okay? Or we could just say for all rational numbers, right? Because it could be the same number, or it could be a different number, okay? So that, such that for all, and we don't have to put other, but for all irrational numbers, okay? And then, how will we finish this thing off?
Just saying the product.
The product of those numbers, good. So the product of those numbers, nice. And then, what's the last part of that?
Does not exist in Q.
Or does not exist in, not just Q, but we have to say, like, what Q means.
Rational.
Rational. So we could say basically is not rational. Okay, good. So, such that the product of those numbers is not rational. Or we could just say irrational. Okay. That's not the only way to say that, that's one way. All right, by the way guys, remember that only the original or the negation is true. Okay, so which one's true, guys? Okay, and this isn't something I asked, but is it true that any irrational number, I can find another irrational number to make their product rational? What do you guys think? Is that true or false? Like for instance, if I gave you guys the number square root of 2, which is irrational, right? Is there a number that I could multiply that by to
Yes,
make it rational?
square root of 2.
Square root of 2, right?
Yeah.
Or square root of 8 if I wanted to, or square root of 32. So, yeah, because root 2 over root 2 is equal to 2, which is rational. How about pi? What could I multiply by pi to make that rational?
Square.
1 over pi,
1 over
right
pi.
guys? Because the reciprocal of that will be 1, okay? Think of any irrational number. Couldn't you just take its reciprocal, multiply by it, and it makes it rational? In fact, that's the process of rationalization, if you guys remember, okay? So it actually is a valid statement, okay? So just in case you guys ever needed to do that, it is possible, okay? We can prove that later in the course. Right now we can't prove it, okay? But at least we know it exists, okay? In fact, later in the course we are going to prove it for any irrational number. I'm going to show you guys a technique to do that. Okay, we're going to go ahead and do this one really quickly. So, for all x and r, so what does this mean, guys? All real numbers, okay? So, for all real numbers, good, there exists, and I'm sorry, what did you say?
A rational number.
Yeah, there exists some rational number, or a rational number. So there exists, we'll just say some rational number such that
The product of those numbers is not
the product is not
in.
an integer. Very nice. Such that their product is not an integer. Okay. And I'm going to give you guys a minute to copy that down. Good. So, easy enough, right guys? I'm just asking you guys to read off what we already know, okay? It's just like a computer program, okay? The first time you guys ever write a computer program, there's symbols, there's lexicons, there's all kinds of stuff that you guys have to be able to read and interpret. It's just like math, okay? As you guys keep getting further and further in your math careers, you're going to find that a math sentence becomes more and more dense, if you would. Like, this is a pretty dense statement, if you would, okay? Because there's a lot of analysis to go on there, and that's what you guys are going to find, okay? John, go ahead, sir.
What is the x and y, like the difference between
Oh,
those, I guess? Like is x some and then y is all, or is that?
what we're saying is that because x has the for all symbol before it, we're just saying that in the domain of real numbers, for any real number you want to exist, okay? So if you thought of a real number, like e or something like that, there exists some rational number, at least one. Because remember, e means that there is at least one, such that their product is not an integer, okay? And think about this. If I had the number e, if I multiplied that by a half, that would be e over 2, right? That's what we're saying, is that if I pick any real number that I want, and then I multiplied it by a particular rational, that means that it wouldn't be an integer for that, which is certainly true. Okay, that's all we're saying with that. Okay, does that help out a little bit with that?
So it's like, why would be the 1/2?
Right, correct. This would be just some arbitrary but particular value that I pick. Okay.
Yeah.
And then we're not, and again, we're not trying to prove it or disprove it. We're just taking the negation of it for right now. Okay? Yeah, don't get too hung up on proving or disproving. That's the next section that we're going to be looking at. Okay. Other questions, guys? Okay. Let's take a look at universal modus ponens and modus tollens. Okay? So we've worked a lot with modus ponens. We've worked a lot with modus tollens. Okay? They're all fairly easy, not meant to be too difficult. We know the form of modus ponens. Okay? P implies Q, P, therefore Q. Now, when we try to do this for the universal, okay, what we're doing is we're saying it's true for some particular A, okay? And A could be like dog, A could be, some sort of alcohol, whatever it wants to be, okay? It's just some particular instance, and we can plug it into that predicate, and it will be true no matter what. Same thing with modus tollens, okay? For any value in the domain, we have predicate implies predicate. If not the predicate for some particular value, then not the initial for that. Okay, so our job is just to define these and see if it fits the form. Okay, it's something that we've already done. It's not that big of a deal, but I just want to make sure that we understand how to do this. Okay, so let's take a look at this first guy, and I'll show you guys in particular how we're going to instantiate this. All right. So if a number is negative, its cube is negative, which we know is true. That's not a big deal. X is a particular negative number. Therefore, x cubed is negative. Okay, so I'm betting most of you guys look at that and you're like, well, that's universal modus ponens. Okay, so we have P, which is this. We have Q, which is this. This looks like P. This looks like Q. So initially, most of you guys think it's going to work, and it will. Okay, we have to define our predicates though. Okay, so our predicate. Let's call one of our predicates P of x. What would P of x be equal to?
If number is negative, number.
Okay, so we would say x is negative, right?
X is negative.
Since we're defining P of x to be an x, okay? So we're going to say x is negative. Nice. Okay. And then we also have a second predicate, which is q of x. Okay. And how might we define q of x in this instance? X cubed is going to be negative. Okay, good. So the cube of that number, we can say x cubed. I want you guys to notice that both of the gentlemen did not say if x is negative, then x cubed is negative. Okay, they just literally made a predicate out of this. Okay, so when you guys are doing these, don't use the words if and then. Okay, that's not a predicate. That's a conditional sort of thing. All right, so those are our definitions. And then we probably need to define what x is. So this is going to be x is a particular element of a particular domain. Okay. So what domain could you guys restrict x to? Not saying you have to, but one of the domains that would work. There's several.
Real number?
We could say x is a real number. What's another domain you guys could use? Integer value if you wanted to. Okay, because it says it's going to be, well, not necessarily an integer, it just says it's a negative number. Okay, so I guess we couldn't limit it to integers in this case. So I think real numbers might be the safest thing to limit this to. Okay, so does that make sense, guys? When we're defining it, we have to define everything.
Wait, why can't an integer be negative?
Oh no, it can.
Yeah.
But we're just saying a number is negative.
Oh, gotcha.
Right, so an integer certainly could be negative, but it could be rational, it could be complex, etc. Okay? Does that make sense, guys? Any questions about that? So if I want to set this up, okay, just reading this, if a number is negative, then its cube is negative. P of x implies Q of X. I think everybody agrees with that. Okay. X is a particular negative number. So how would we write the second line there, guys? Not Q of X, but P of X, right? Because we're just saying X is a particular negative number. So this says, if X is negative, then X cubed is negative. We're saying X is negative, and X is a particular real number, okay? And X is a particular negative number. Therefore, what will be the conclusion? Oh, go ahead.
Wouldn't you have to put it on that where P of X is, you'd have to state that it's negative?
No, we're not, because what we're saying right here is that X is a real number, and we're substituting it back into this, okay?
Oh, you're just saying, you're defining X as
Correct.
negative already.
Yes, sir.
Right.
Okay? So by putting it into that predicate, we are saying that it is indeed negative. Okay? And remember, it's following a logical form. We don't know if it's true or false, but if it does follow that form, then it will be true. Or we'll see that it will be true. Sorry. Okay. And then, therefore, guys, what can we say is the conclusion?
Q of X.
Good.
Now, on universal mode exponents, we always have to define the domain, right?
You should define the domain of the instance that you're using.
Okay.
Okay? If you don't do that, then unfortunately it's not completely correct with that. Okay?
Okay.
And as you see a few more examples, it might make a little more sense.
Gotcha.
Okay. Is that okay with everybody, guys? Any questions? Okay. So now, this is obviously going to be true. It follows the universal modus ponens. So we're good with this. Okay? So we're going to say valid. By modus ponens. Okay? That's all we have to do with this, guys. It's not meant to be difficult at all. Okay? Is that good with everybody, guys? Any questions? Okay. Sometimes it works, sometimes it doesn't work. Okay. So let's take a look at another example. Okay. So if a polyhedron has 4 sides, then the sum of the angles must be 360 degrees. Okay. The sum of the angles of a particular polyhedron S is 360, therefore S has 4 sides. Okay. So again, we're going to define some predicates. So let's start with P of X and Q of X. I don't think we need more than 2 predicates. Okay. So, what do you guys think we define P of X as?
If polyhedron has 4 sides.
Not polyhedron. Good try, but X has 4 sides,
yes,
right? Because we're saying it's a predicate when we substitute values for X. Okay? So we would say X has 4 sides. Okay? Notice we didn't say if X has 4 sides or if polyhedron has 4 sides. Okay? Does that make sense to everybody, guys? Whatever variable you're using here, you better use on the right-hand side, just like a computer program, right, guys? If by the same fashion, what would Q of X be then? And there's multiple ways of stating this.
The sum of X must be 360?
The sum of X must be 360. Very nice. Good, Andre. So, the sum of X, whatever X might be, must be 360. Okay. So, does that make sense, guys? Any questions? We're just starting out with X's. There's one other thing we have to define. We have to define something that we're going to plug in for X. Okay? So what can we define first of all? Or what should we define by looking at our problem? S, right guys? We have a particular polyhedron S. So we're going to say S is an element of polyhedrons, right guys? Because that's the domain that we're looking at. We're saying a particular polyhedron. So S is a polyhedron. And now what we can do is we can start to build our universal modus ponens or tolens, or see if it's an error. Okay? So at this point, guys, we can go ahead and finish this off. Okay? So if a particular polyhedron has 4 sides, then the sum of the angles must be 360. Guys, wouldn't we agree that that would be P of S implies Q of S, right guys? Because now we're starting to talk about that particular polyhedron. Okay? And we're plugging that back into the predicate. So once we have our definitions, we just substitute them into the predicate. The sum of the angles of the particular polyhedron S is 360. Okay? So what would the next, I guess, the next line of this be?
Q of S.
Q of S, right guys?
Mhm.
Because it says we define Q to be the sum of the angles, or the sum of X must be 360, so this is going to be Q of S. Therefore, what guys? P of S.
Yeah.
Nice. And unfortunately, this doesn't follow the modus ponens, or modus tollens, right? So this is invalid. If I was to ask you guys for a particular reason as to why this is invalid, now I know we looked at this maybe on assignment 1, but go ahead. No, go ahead.
Inverse error?
Not inverse,
Converse.
but converse, right? Because that's okay. You had the right idea. Don't worry about it. Just don't do that on the exam. You'll be fine. Okay? Guys, notice that we flipped the P and the Q. Isn't that a converse error?
Mhm.
Right, guys, when you flip those around. Nicely done, sir. So this is indeed a converse error.
Inverse will be like not P and not Q, right?
Correct. That would be not P of S, therefore not Q of S. Okay. All right. Questions about that one, guys? Okay. We could do the same thing for the next one. Okay. So the next one says all insects are small, dogs are not small, therefore dogs are not insects. Okay. So let's define a P of X and let's define a Q of X. And then we'd have to define something particular. Okay. So what's one of the two predicates that we could define here? These are a little bit sneakier. Because, was it? And X is an insect, maybe. How about that? Would that work, Donnie? Because we have to put it into the predicate form. Nice, okay. So let's say that P of X is an insect. So I'm trying to make sure I set this up nicely for you guys. So, yeah, that'll work. So X is an insect. Okay. What would the other predicate be, you guys think? For Q of X? X is small. Okay, that sounds good. Because, and I know this one's a little bit more difficult because it's not an if-then, okay? We're going to convert it into one of the conditional statements, okay? So I like it. X is an insect, X is small.
Not small.
Now, well, no, that's the second line. We're still in the first line here.
Oh, okay.
Okay? Now, next we're going to get to the negation of this.
Got it.
Okay? Does that make sense, Art?
Uh-huh.
Okay. We need one more thing, right, guys? What's the only thing we need? We need our dogs, right? Okay? So, where are my dogs at? So, let's define D. Now, D-O-G-S, right? Not D-A-W-G-S. Okay? Like, suck dog with the drawn out all. Okay? We're just going for the mammalian. Okay? Alright. So, does this make sense, guys? Any questions so far? Now we can start to build our predicates. Okay? So, if I was to ask you guys to build this, okay, now be careful. Okay? The first part says all insects are small. Okay? How can I write that into a conditional statement? Because to show universal modus ponens or universal modus tollens, it has to be conditional. So, any idea how I might build that? So,
If X is an insect, then they are small.
So, if it's an insect, then it is small, right? So, in other words, if I wrote this, so would that satisfy what you were thinking? Yes. If X is an insect, then X is small. Okay? Doesn't that make sense, guys? It says all insects are small.
No.
So we can convert that over. Okay? Does that make sense to everybody, guys? I mean, it should just resound in your head that it's met the first part, so it has to follow the second part. Now we can start talking about the dogs. Okay? So it says dogs are not small. So, if I was to try to create a secondary statement,
Would it be not Q of D?
not Q of D. Correct, sir. Okay? So, X is not small, but now we're talking about dogs. So it'd be not Q of D. The first part, we don't have anything plugged in there. Okay? It's just general. The second part, now we're plugging in the dogs. Okay? Nicely done, sir. And then finally, for the conclusion, guys,
No.
not P of D, right? Because the last part says dogs are not insects. So it'd be not P. And clearly, guys, doesn't that fit the universal modus tollens for this one? Okay, you guys can look at it, and it fits perfectly into there. Okay, so we're going to say this is valid by the modus tollens.
Even though the domains were different, so it doesn't matter. And
Right, because the first one is just for anything. Okay, like if I said, if brick is an insect, then brick is small. Okay? Or if Toyota is an insect, or whatever it is. We don't know what we're particularly plugging in there. Okay? And remember, it doesn't matter if it makes sense to us in the real world. It's just logically correct. Okay, if it follows the form. Okay. So, does that make sense to everybody, guys? I want you guys to try to separate your real world definition of logic versus the formal definitions of logic. Okay, so that's all we're doing with this. Okay, so last thing we want to do, okay, very similar. Okay. So it says all real numbers or all rational numbers are real numbers, okay, which is true. All right, and then we have 2i plus 5 is rational, therefore 2i plus 5 is not real. We know the conclusion's true, but are the steps that we took to get to the conclusion true? Probably not. Okay, so let's define a P, let's define a Q. Okay. So, what are our two predicates for, or what's one of our predicates?
X is a rational number.
Yeah, we could say X is rational, or X is an element of rational, couldn't we, guys?
Yep.
Because it could be true or not true. So we could say X is an element of, by the way, what's the symbol for rational, guys? I forgot. Q, because it's the quotient of two integers. And then the second line, and by the way, if you wanted to just write out X is rational, that's fine too, okay? I don't care either way. Okay.
X is real.
X is real, which would mean, and if I wanted to write symbolically under it, X is,
It's, right. No.
Fancy R.
Yeah, yeah.
sorry about that, called you off guard. But no, you were right, I saw the hand motions and it worked out. Good enough. There's one other thing that we need, okay? What's the other thing that we need to define, guys? 2i plus 5, okay? I'm going to call that just some sort of number. Believe it or not, for some reason in complex numbers, what do they usually use? Does anybody know what variable they use to represent a complex number? It's usually z for some reason, which is confusing because they use z for integers. So for those of you guys that have to suffer through complex analysis ever, I saw this so many times with z. All right. But they usually reserve x and y for real parts, and they refer to z as like the complex part,
Z
or
is
the
also
argument. What's that?
integer too, right? Z is also
Well, z is the set of integers.
set of integers.
For some reason, in complex theory, they use z to represent a particular complex number. Okay, so it actually makes sense. Well, I'll show you for those of you guys that are interested another time. But you can express a complex number as an angle. I don't know if you guys ever knew that or not, but yeah, in complex theory, you can do that. So, but don't worry about that for right now. So, because you can convert a complex number into a sine and a cosine value by using, I think it's Euler's theorem. But yeah, never mind. Sorry, I'll shut up. I really want to talk about it, but I'll talk about math instead. So if I want to try to go ahead and do this, all real numbers, all rationals are real. How would you guys define that?
Q of X. That implies Q of X.
Nice. If it's rational, then it's real.
Mhm.
Okay. Next line would be
P of Z.
P of Z. Okay. So Z is a rational number, and then it says therefore it is not
Q
real,
of Z.
not Q of Z. Okay. So take a look at that, guys. Make sure that makes sense. Okay. Any questions about how we set that up? Nicely done, sir. Okay. Obviously, that doesn't look like anything, just a hot mess. So you would just say invalid. It's not even a type of error because it doesn't even come up that often. So you would just say invalid. Okay. Not modus ponens or tollens.
Do we have to write that, or could we just say?
If I ask for a reason as to why, and I think I do, maybe I say why or why not. I don't say why, but just in case I do ask for why. So you just say not modus ponens or. Okay. So if it's not a converse error or if it's not an inverse error, that's what you guys would write. Okay. All right. Questions, guys, about this one, this stuff? Hopefully not too difficult, maybe a little bit sneaky on the setup, okay, but other than that, I don't think it's too bad. Okay, another way to be able to determine if universal modus ponens or tollens is true is by using Venn diagrams, okay? And I know Venn diagrams sounds like it's fairly easy, and it should be fairly easy for us, okay? Generally, there's going to be two components to a Venn diagram, okay? So, one of the major components, if I was to draw a Venn diagram logically, okay, this big guy is called the major premise. Okay. And then inside of the major premise, there may or may not be something called a minor premise. Okay. Now, I'm not saying that these all look like this. Okay. You might have several minor premises, you might have several major premises. It's our job to be able to try to construct these graphs. One of the hardest things, I think, for students is determining what's the major and what's the minor premise, okay? Hopefully, after we go through 4 examples, it won't be that big of a deal for you guys, but if it is, just let me know, I'll try to re-explain it to you guys. Okay, so this first guy should be fairly easy, okay? So, all teachers make mistakes, gods never make mistakes, therefore teachers are not gods, depending upon which teacher you talk to, all right? Maybe some of the engineering teachers on campus, not naming any names, but regardless. Okay. So, no, I didn't say any names. You might be right, Don, but regardless. All right. All teachers make mistakes, all right? Guys, there's 2 predicates going on there, okay? There's going to be X is a teacher, right? And X makes mistakes. Which is the major premise? You got 50-50 shot.
All teachers.
Unfortunately not.
Makes mistakes.
Makes mistakes
Hey,
is the
don't do
big
that on the
premise.
exam.
Okay, that's all right. That's why we're doing this now, right? So that's why we take classes. Okay, so if I was to make a Venn diagram out of this, the major premise is people that make mistakes. Okay. How do we know that's the major premise? Because all teachers make mistakes, right, guys? So wouldn't all teachers have to be contained in the people that make mistakes? So the minor premise to this would be teachers. And I know teachers comes first, and I know the word all is right next to teachers. That does not make it the major premise.
So the verb should be the major. You can
Not
say-
all the time. You just have to see what's the subset, okay, if you would. Does that make sense, guys? It says all teachers make mistakes, so teachers have to fit into the group of people or things that make mistakes. Okay. Now, we also have gods never make mistakes. Okay, so where do gods go? Outside, right? So right out here. Okay, I'm going to put, and I'll use lowercase letter g as to not offend anybody. Although I probably offended somebody by using lowercase letter. I probably offended somebody by standing up here and using a pen that isn't made of like fiberglass or something like that. Regardless, don't give a shit. Okay? This is right. Guys, doesn't it show right there that that it's valid? Okay? So, we have teachers, we have make mistakes, we have gods never make mistakes, therefore teachers are not gods, they're outside of that. So guys, we can evidently see that this is valid. Okay, so we can say this is valid by diagram. And that's all we have to do. By the way, this is actually an example of universal modus tollens. Okay, it's a contrapositive. Okay, if you wanted to write it out like we just did the other 4 examples, you could see that.
Oh, so basically when you draw the major and the minor, we have to first focus on the first sentence, then the second sentence is for gods, whether it falls.
That's the particular instantiation. Just like over here, remember we defined several different variables? That's exactly what the second sentence or the second part of this is going to be, the second premise.
Gotcha.
Does that make sense, Art? Okay. Yeah, me too. All right. All polynomial functions are continuous. Again, we don't care if it's true or false. Okay. What's the major premise for this?
Are continuous.
Continuous functions, right? So basically we have continuous functions as the major premise. So right here we have our continuous functions. And then guys, the minor premise would be what?
Polynomial.
Polynomial functions. Okay? So, here right here, we could just have polynomial functions. Okay. So, now you guys caught on really quickly, okay? Whatever the for all is has to be settled inside of the major premise. Okay? 1 over x is not continuous, so, oh, sorry.
So is it possible to have like an even broader premise?
There could be, yeah, even majorer premises,
So
or
just
premise.
put another like ring around?
Right, that's correct, if necessary, okay? So, now I'm not saying I'm going to be that being to do that, okay? I'm only going to stick to 2 at the most, okay? Alright, guys, 1 over x is not continuous. Where does 1 over x go?
On the right.
Outside everything, so it looks just like the previous, okay? So, we're going to put 1 over x. It should be y equals 1 over x, but not that it matters that much. Clearly, the conclusion's true, okay? Since 1 over x is not continuous, it cannot be a polynomial function. So once again, I can't really squeeze it in anywhere, but I'm going to valid by diagram. Okay. So guys, if you wanted to prove something true, that's how you'd have to prove it. Okay?
And
Nothing to
if the conclusive statement said 1 over x is a polynomial, then we would say that invalid by diagram.
Correct. I'll show you some invalids.
Okay.
There's multiple ways to show invalidity.
Okay.
Okay. All right. Other questions, guys? Okay. So, our third example here. Okay. All students eventually study. Chris will eventually study. Therefore, Chris is a student. Okay. Now, if you guys were to write this out symbolically, you would see that this is a converse error. Okay. Because notice what we did was we put the second predicate first, and then the first predicate second is the conclusion. Okay. So that's like begging the conclusion, if you will. Let's just go ahead and draw what we know to draw. Okay? So, all students eventually study. What's the major premise? Eventually studies, right guys? Because all students have to go in there. Okay, so that's eventually studies. And then in here, let's just have students. Chris will eventually study. Where does Chris go? Inside the students, maybe.
You know he at least goes and decide
Oh.
and eventually study.
Okay, so he could go here, right? But Donnie, what you said isn't wrong. It could go right here as well, right? Because all he says is that Chris eventually studies. So Chris could go and eventually studies. But it doesn't say that he's not a student. Or she. Sorry, he may be gender biased. Okay, so this is our students. This is Chris.
It does say he's a student. Chris is a student.
It does.
So,
For the conclusion.
so you have to you have to draw both possibilities?
Yes. And I'll explain what that means in a moment. Okay, so eventually studies. I'll get that guy's way in a second. So, which one of those is correct? Both. Which one do we pick? We can't pick both, okay?
You pick
Get the broader one.
either one.
Well, it's or.
The second one.
Well, we like the second one, but we don't necessarily know if that's true, right?
But the first one.
So we pick the first one.
Well, actually, they're both true, right? We don't know which one to pick. It's an ambiguous case. So, because we don't know which one to pick, we can't state validity, okay? We're basically saying that they're both true, but I can't pinpoint which one to pick, okay? So there's ambiguity that's going on with this, okay? That's where the converse error comes in, okay?
Why can't you assume that the first one's always going to be true? And that's
Oh, you can!
definitely right.
That is correct. This one is definitely true, but this one could be true, okay? So we can't say with certainty which one to pick. That's the problem.
I think what's confusing is it's like an or thing, and like
Correct.
the statement's going to be true.
One of them's true, right?
Yeah.
This one's always true, but this one could be true. So because we don't know which one to pick, there's invalidity there. There's a contradiction.
Anytime you have two possibilities, can be invalid.
That's exactly right. If you, That's okay, you're absolutely right there.
Okay.
Two possibilities invalid, and they're both correct possibilities. Sorry, I have to make sure that it's
Two
true.
correct possible.
Right.
By putting Chris inside with the students, what exactly does that achieve? Like, how does that change the two different?
Oh, okay. Well, this one's not true, right? Because the conclusion is that Chris is a student.
Yes.
But this one is true because it shows that Chris is a student. So we're saying that this one's not valid, but this one is valid.
So why don't you pick the second?
Ah, how do we know for sure that? We don't know for sure.
It's just the fact that both of them provide different bits of information. So they
Correct.
both have something that's true in them, but they don't present the whole case.
Right.
There
Okay.
could be a time where either of them is true.
That's correct. And we just don't know. Okay, does that answer your question?
Yes.
Okay. So basically, guys, what we would say is that this is invalid. Okay. Because there are two possible valid diagrams. So invalid. Yeah, two possible valid diagrams.
Is it invalid in general, or just by using Venn diagram?
It's actually invalid because if you were to do what we did over here, John, we would actually see that it's going to be a converse error. But remember, I asked you to do it by using the Venn diagrams. Okay? So, guys, that's the way I always think about it. If I give you one of these problems on an exam, I would just check it symbolically first, and you already know what the answer is going to be. Then you can use, and you can finagle your Venn diagrams to support your answer. Okay? So, does that help out a little bit, John, with that? Okay. Good. Other questions, guys? Okay. Yeah, a little bit sneaky. Okay. Last one. No gentleman smashed phones with a bat. David Ortiz is not a gentleman. Therefore, David Ortiz smashes phones with a bat. Okay? So, we need a major premise, we need a minor premise. Okay? So, what's the major premise for this thing? Smashes phones with a bat. Okay? Because no gentleman would be outside of that. Okay? So, we're going to have our major premise, smashes phones with bats. SFWB. SWAB. Okay? But outside of that major premise is going to be gentlemen, right? Because not one gentleman would ever smash a telephone pole or telephone with a bat, regardless of how baby-fied that baseball player may be. Okay? So out here, we are going to put gentlemen. All right. So where does David Ortiz go? Hopefully not to the Hall of Fame. Steroids don't allow that. But apparently some discussion says that there should be. So, regardless.
So
Where
David,
does Mr. Ortiz go?
so David Ortiz is not a gentleman,
He is
right?
not a gentleman, that's correct.
So that's another, that's an,
He could go inside, he could go outside, he could go to hell for all we care, right? I'm not saying I want that, but, alright. So, this could be Mrs. Ortiz, or Mr. Ortiz, I'm sorry, okay? Or, there could be another diagram, right guys? This is another ambiguous case. Let me draw another one over here. Sorry about that, guys. I ran out of one. Over here. Give myself a little bit of room to construct this. There's actually going to be two diagrams. So, now we still have our smashes phones with bats. And then we have our gentlemen. But isn't it true, guys, that Ortiz could go in the category of smashes phones with bats? Okay. So what we see once again, just like in the previous example, is that there are two possible Venn diagrams. Okay. We don't know which one to pick. One of them satisfies the universal modus ponens for this. The other one does not. Okay. So what we would say is once again that this is invalid. There are two possible Venn diagrams.
The reason we have two different ones is because David Ortiz is not a gentleman. That's the main thing.
Correct, right. If he were a gentleman, we wouldn't even be talking about smashing phones, okay? Nor would we have the idea that this is going to be invalid, okay? Does that make sense? Yeah, I think you answered it very nicely. Okay. Guys, questions I can answer about this? Okay. So, John Biden, sir.
Yeah, number 3 on, so like the second circle, like the middle one is student and Chris?
Correct. Chris is a subset of these students, right? Because what it's saying is that Chris will eventually study. So Chris could be here, or Chris could be inside students, right? Because if he's inside students, he still will eventually study. But we never said that Chris is not a student. So we can't say with any certainty that Chris is inside this circle or outside that circle. That's why we have 2 different diagrams. Just because there's that ambiguity as to whether he eventually studies and he's a student, or it's mutually exclusive that he just studies but he's not a student. Okay. Does that make sense, John? It's just that he could be in either one of those. We just don't know which one. All right. Other questions? Okay. So time to play good news, bad news. The good news is that we've gotten all the material that's necessary after the first exam. What's the bad news?
The
We
exam.
have to take the exam, right? So let's talk about the format of the exam, and then if you guys have some particular questions for me, I can certainly answer those for you guys. Okay? Generally, the first examination is about 15 questions. Okay? They're either 5 or 10 points apiece. And they're just like the homework questions. Okay? The homework questions are just basically to set you guys up for the exam questions. So anything that we've done for homework is essentially going to be the format of what to expect on the exam. Okay, so I'm not trying to trick you guys or anything like that. It's all free response. Oh, go ahead, sir.
David, are you going to be on the exam?
No, he's much too large to fit on any examination, or most rooms for that matter, as well. Okay. So no David Ortiz. So. Any Red Sox fans in here? Good that nobody raised their hand, because you would automatically fail down the road. Sorry. No, I wouldn't fail if I for that. Okay, so first exam, like I said, about 15 questions. Okay, and if you guys want to get an idea of what to expect, assignments 1 through 3, and then also exam 1 review. That's some good places to go and study. So exam review number 1. Okay. Just to kind of give you guys an idea of how I kind of work this. The first 60% of the exam is going to be like the logic stuff, the truth tables, the Boolean algebra, the number bases, the logic circuits, and then the other 40% is the stuff that we've done most recently. So let me just kind of give you guys an outline of what to expect with this. Okay, so one question I'll certainly ask you guys. I might ask you guys to verify using a truth table. Okay. Like for instance, I might ask you, P implies Q and R is equal to P implies Q and R. Okay. So basically you would either prove it or disprove it by using a truth table. Okay. And you guys know how to do that, right? You guys make your truth table. If the right-hand side equals the left-hand side, it's good. If any of the truth rows are different, it's false. Right, guys? We know how to do that, and that's not a big deal. Okay. Another question I could ask you guys regarding this sort of stuff with the truth tables and logic is, I'm definitely going to ask you guys a Boolean algebra question. Okay. And I don't know if this works. Don't go home and try this, but just to give you guys an idea of what I'm thinking, maybe something like Pn not P or Q, and Pn not Q, or not P and Q or something like that, is equal to P. Okay, like I said, don't go home and try that. Okay, but yes, sir.
And we can use the cheat sheet.
Oh yeah. You can use the list of all the different rules on there. Yeah.
Okay.
So make sure you guys have that with you guys. Okay.
You are not going to give this like a basic rule of inference or the one that you gave us? What is that called?
You mean the one that says
Yeah, this one. Right? You're not going to give us this one?
No, you bring it.
We have to bring it?
Yeah.
Okay.
Yeah, just bring it for yourself. If you lost it, go online and print it out. Okay. If you can't go online and print it out, then Sorry.
How big is the note card?
3 by 5.
3 by 5.
Yeah. Okay. I'm trying to think of some of the other stuff we did regarding this. We did this stuff with the argument forms. Okay, so I might ask you guys to like prove or disprove by table. Okay. Maybe something like P implies Q, Q implies R, therefore P implies R.
That's transitivity, right?
Oh yeah, it's transitivity, but I'm just saying something like that. Okay, so yeah, and the ones I write up here, guys, these are just like what I'm going to give you. It doesn't mean it's going to be that exact one. Okay.
So this is pretty much structured just like the exam review is now.
Just like the
This
course,
is-
just
this
like
is-
the exam review, just like the homework.
Okay.
Okay.
'Cause this is
I'm trying not to fool you guys. Okay. So if you think I'm trying to fool you, then you might have been asleep for the past month or something like that. Like I'm literally doing stuff in order. Okay. So yeah, I'm trying to make it like in the same order and all that stuff. Okay.
What kind of stuff will be allowed to put on the note card?
Whatever you want. So I don't care what you write on there. That's your new card.
Oh, okay.
Is it single side or both sides?
Both sides. I don't care. It has to be a handwritten note. You can't type it. Okay. All right. I'm trying to think. I might ask you guys, and again, I say this again and again and again. Don't go home and try this because I don't know if this works. Okay. But I might ask you guys to use the rules of inference. Okay. So I might ask you guys, like I might give you like P and Q implies not R. Not R. S or not T, like some other stuff, therefore not T, okay? But you guys know what I'm talking about, right guys, where I just give you a whole bunch of them, you have to use the rules of inference at the bottom. It was the last question on assignment 1 that I asked you guys to do on assignment 2, okay, that stuff, okay? So, I think right there, those are like 4 good questions that I could ask you guys for 10 points apiece, okay? They're of high level of caliber to ask you guys to be able to do something like that, okay? I'll give you guys some easier ones like converse, inverse, contrapositive. Like if I give you guys a sentence, you guys should be able to do that. So, write converse, inverse, contrapositive. Of some sentence, okay? Trying to think.
And
So-
symbolically, right?
Yeah, either way, sentence or symbolically. Although, if you have to ask you guys to write symbolically, that's really easy. So, okay. Trying to think of some of the other stuff we did with the logic. What's that? Well, with the logic stuff, I'm getting to the circuits and number bases because I already know some of the stuff there. But I think that's probably good for the logic stuff. If you guys are good with that stuff for logic, I can't see you guys not doing well on that part. Okay. With the logic circuits. What I'll probably do is I'll probably give you guys 2 questions where you have to go to another form, okay? So, probably like 6 and 7 will be logic circuit stuff. In fact, I know it will be.
Is the test already made up?
Oh, yeah, it is. Okay, so logic circuits, like for instance, I might ask you guys to go from a table to a circuit. I might ask you guys to go from a circuit to a table. I might ask you guys to go from Boolean to the circuit. I might ask you guys to take a circuit and write the Boolean expression for that. Okay. So just make sure, guys, that you guys can go back and forth between the different forms that we've looked at. Okay. And all of those we've had for homework, all of them we've done in class, so that shouldn't be that big of a deal for you guys. I'll definitely give you guys like one of the number-based problems where I give you guys one of the 3 different types of bases, and you go to the other 2. Okay. So I might, for instance, I might give you guys something like 3 to C in base 16, and what I'd like for you guys to do is to go to binary and decimal. Okay. Or I might give you the decimal and you go to the other 2, or I might give you the binary and you go to the other 2. All right, just delicious. Just make sure, guys, that you can go back and forth between the different number bases. Okay, and of course show your work. Obviously, if you have a calculator that does it for you, I don't mind that, but you got to be able to show your work as to how you got there. Okay. The last question I'm definitely going to ask you guys with regard to the logic circuits and the number bases is the 8-bit addition. Okay, so make sure that you can add something like -17 base 10 plus -31 base 10 using 8-bit addition. Okay. And when I say 8-bit, make sure you actually use 8 bits. There were several of you guys that decided you were going to make up your own system with 6 bits. Okay, you got to use 8 bits when it says 8 bits. Okay.
Are we gonna have to do that rule, negative rule, or whatever?
Oh, the 2's complement? Yeah, yeah. In fact, for that problem, you'd have to use the 2's complement twice. Okay? In fact, 3 times. You'd have to use the 2's complement, once for each of the negatives, and then once for the solution since it's negative. Okay? So yeah, guys, this part of the examination, probably about 60% of the exam stuff. Okay? So, any questions about that, guys? Bless you. Okay. So, hopefully, guys, that's not too difficult. If I was to focus on anything, guys, probably the 3 questions that traditionally give students trouble: Boolean algebra, as you probably already know, rules of inference, which you probably already know, and then the 8-bit addition. Okay, so I would go back, make sure you guys are good with those 3. Okay, because I see, like, you know, traditionally as I taught the course, those are the 3 that give students the most trouble. Okay.
Can you go through an example of the rules of inference problem?
Oh yeah, sure. In fact, let me lay out the rest of the examination. And Donnie had a question, and I'll do one of the rules of inference for you as well. Okay. And then if you guys have other questions, I'm happy to do those too. Okay. All right. So for the remainder of the examination, that's the stuff that we've been working on Wednesday and then today. Okay. So for instance, guys, for number 10, okay, what I've always done is I've given you guys like a sentence and you write it symbolically. Okay, so like if I said, all cats smell badly, write that using the for all symbol. Okay, or if I said, some people use steroids, make sure you guys can write it using the exists. Okay, so basically the very first thing that we did in this section, right guys? Okay. For number 11, what I'll ask you guys to do is I'll ask you guys to write the negation of those sentences. Okay, so that's 10 easy points right there. So for number 10, negation of each of number 10. I'll do the same thing for number 12, except it'll be a conditional statement. Okay, so like I might say, for all beers, if X is king cobra, then X tastes horrible. I don't know how many of you guys can attest to ever drinking a king cobra malt beverage, but on a scale of 1 to 10, it's like a -75. It's pretty horrific. Okay.
Natty Bo too.
What's that?
Natty Bo.
Yeah, Natty Bo. Well, it depends. Depends on what other beers I've had already. So.
Dosaki.
Dos Equis is good.
Good. Dosaki is really good. Yeah.
So, all right. So what I'll do is I'll ask you guys to write this symbolically. Okay. So. And then also what I'll ask you guys to do is I'll ask you guys to write the negation of this as well.
In the same question, or would that be?
Yeah, I'll just make it the same thing. It'll probably be worth 5 points. So 2.5 for writing it symbolically, 2.5 for writing the negation. All right. We have the multiple quantifier stuff. So what I'll probably do with the multiple quantifier is I'll give you guys the multiple quantifier statement, you translate it to English, and then you write the negation of it. Okay, so like for instance today, and I don't know if this is the same one we did today, but for all x in I, there exists y in I such that X, Y in Q. Okay. I'd ask you guys to do two things. I'd ask you guys to write this in a sentence, and then also to write the negation symbolically. So literally, guys, like one of the problems that we just took a look at not too long ago, okay, today, that would be fair game. I think I forgot to put, I know we did this earlier, but remember we talked about like, what is it, counterexample and existence and exhaustion, where I give you guys like a domain and you have to prove one of the statements using that. So somewhere up in here, I'll probably give it to you like before all this stuff. But let's say I give you guys the domain D is equal to 1, 2, 3, 4, 5. I would ask you to either prove or disprove that for all x in D, 2x in Z even, or I might say there exists x in D such that x greater than 1 over x. Okay, so something like that. Okay, hopefully not too difficult. Okay. And then the last problem I'll ask you guys to do is I'll ask you guys to do something with either the Venn diagrams or the universal modus ponens or tollens. Okay, so it's one of the two. Okay, so either Venn diagram slash universal modus ponens, modus tollens. Okay. All right, so that should be enough to keep you guys busy for a while at least. So I'll give you guys a minute to copy all that stuff down. But I don't think anything up there we haven't gone through or you guys haven't had for homework. So like I said, I'm not trying to trick anybody. You know, I mean, it is what it is. All right, so questions about the content of the examination before I do answer like a couple questions for people pertaining to.
Let's say 2x in Z.
Oh, 2x is in Z even. So yeah, sorry about that. I'm just trying to scratch it down to get it out of the way. Okay.
So is this going to be like an open book, open instructor, or open neighbor?
For
help?
No. Well, actually, you can use your neighbor, but you both get zeros.
Oh, okay.
So feel free to do that if you want to. It'll make it really easy for me to grade it. You can also use open book, and once again, you get a 0 for that.
What about open instructor? 100?
Well, then I'll start giving you wrong answers. So yeah, you can use me if you want, but I wouldn't trust my answers necessarily. Okay. So like I said, guys, the things you can use for the examination, okay? So for materials, you can use one 3x5 note card. Okay, you could use both sides of that. I don't care what you guys write on there. You can write examples. You guys can write whatever you want. Okay, but it has to be handwritten, and it can't be photocopied. So it has to be handwritten in your own handwriting. Okay, so. And I will ask you guys to submit that as well. Okay. And then you can use. What's that?
I could give that to you.
Yeah, I'll staple. What I'll do is I staple everything together, so that way for the final it's all in one place for you guys to study for. Okay,
So
because the
write
finals
small
can't.
enough so you can't read it.
Oh, sure, that's fine. I mean, if you guys can read this, I can read whatever you put together. Okay. So, and then also, guys, you can use the rules of inference sheet and the Boolean algebra sheet. So I would definitely bring that. So Boolean laws / rules of inference sheet.
We can't have anything written on that, though, right?
No, and if you do have, well, I mean, it depends on what's written on there. Like if you have your name on there, that's fine. If you have like puppy dog tails on there, that's fine. But if you start having stuff that like, you know, that would help you on that, then I'd ask you to print out a new copy of that. Okay? And what I'll do is I'll go around and look at everybody's before the test just to make sure it's legit. Okay? And then also, guys, make sure you bring paper to do the problems on. what I give you is I just give you guys like the exam, and I don't even look at the exam for anything. So if you write all of your answers on the exam, then you just got a 0. So you don't want to do that. So make sure you bring paper, calculator, bribes.
Dos aquí.
Yeah, Dos Equis works nicely. Okay. Money works well. You know, whatever. What's that? Make sure it's in an envelope if it's money though. So, okay. So, any other questions, guys, I can answer particular to what's going to be on the exam and that sort of stuff? Okay. So I did have 2 questions that you guys asked me to work. So Donnie, you want me to work one of the Boolean algebra ones?
I think it was 3.
Okay, and that's fine, and then I'll work. By the way, I am working through the solutions to the exam because of the exam review. I've had many people ask about it, and I told some of you guys that today was borderline between insane and suicidal, so I apologize that I haven't gotten to it, but it's pretty bad, like, you know, when your boss tells you that you have a 2 o'clock appointment at 1:45, and she just made it up, and that's during my office hour, and then my girlfriend gets in a car accident. You know, all within a 20-minute span. Ha 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 ha.
Sorry to hear that.
Funny day. Yeah, it's been a great day. Awesome. Yeah, real fun.
Did you look this up?
What's that?
Did you look up the question?
I have not. I'm sorry. I will post that on Blackboard. The problem I made up has nothing to do with that. Okay, so
As long as we don't need
right.
that.
I will not screw you guys with that question. I promise. Okay. All right, Donnie, can you read that all for me, and then I'll go ahead and kill it for you.
Parenthesis, P and parenthesis, not P, or Q, parenthesis, or P and Q.
And that's supposed to be equal to P, hopefully?
Yes.
Okay. All right, and maybe some of you guys worked through this already. All right. Donnie, I'll ask you, how did you start that?
I didn't start.
You didn't start it. Okay, well, that might be a good thing, that you didn't do it wrong.
You had
Okay.
to name
Yeah, I understand.
them. No, in the,
Okay, just take one out.
well, it kind of matters which one you take out.
Okay, well, take out the one that doesn't belong.
The
Does
one,
that make sense?
Your answer can vary depending on which one you take out.
the first you do the
Take out the
parentheses.
one that makes the answer right. That's all you do. You know I'm messing with you, right?
Yeah.
Okay, good. All right. Regardless of the number of parentheses, can somebody tell me what they did to start this?
Yeah, P and P or not Q. Double negation. Double negative plus De Morgan.
De Morgan's. Okay, so start by, Donnie, always work inside. Okay, think about like order of operations. You can use De Morgan's law right here, and you can write this as Pn quantity, not P, N Q, and the rest of it doesn't get changed. Okay, so this is, I'm just going to say Dm for De Morgan. If you guys want to couple this with the double negative law like you did, that's perfectly fine. Okay, so I don't have any problem with that.
Wouldn't the Q be negative as well?
Yeah, it would be. I'm sorry, just be a copier, or he didn't be a copier, just a logic error. Thank you, sir. Sorry about that. And then you guys can use your double negative right here. Okay, so this would be quantity Pn not Q, or P and Q supposedly equals P. Okay, so that's your double negative. So dn.
Then associative P and P.
Yeah, for this, and before we actually do it, okay, one of the things I've been telling students that have been coming to my office for help with this stuff is look at the symbols that go in between them, okay? There's only so many different ways that you can write this stuff with the symbols. So my suggestion would be to look for some sort of law that has 2 ands in succession. Or, if it was like something else, maybe an and and an or maybe an or and an and, okay? Guys, if you have 3 things, it's either going to be associative or it's going to be distributive. Okay, that's the only 2 it could be. And because they're the same symbol, you can use the associative law. You can move your parentheses over. So this is going to be P and not Q. Or
P and Q.
P and Q is equal to P. Okay, so that's your associative law.
Then idempotent or whatever.
Yeah. and you guys can see like that if you have P and P, like if I have black marker and black marker, it's black marker. So this is idempotent. So you have P and P is just P. So now we can lose one of those layers of parentheses. So we have P and not Q, or P and Q. Don, you okay so far with this? I'm not going too fast or too slow? Okay. And that's our item totem ball. I just realized I wrote ass on the board.
That's what I was laughing at.
Ass up. I think that makes it any better. Now this is, I think this might be one of the sneakiest parts of the problem.
This is distributive.
Right, this is where you guys have to notice that it follows the form and or and. And there's only one possible law that follows and or and. That's the distributive property. So see how you have like this common P and right here? You're going to factor out the P and, okay? Just like factoring a GCF. And you would be left with not Q or Q. So that would be equal to P, okay? So that's your distributive law. Well, it's reverse distributive law.
Then commutative.
You don't have to use the commutative if you don't want to, but yeah, like to get it to match the worksheet, you'd have to use commutative.
Okay.
If you wanted to skip that commutative step, you could see that, I think it's the negation law, not Q, or not P, or P, or P, or not P. Isn't that its tautology? Yeah. So this would become P and tautology is equal to P. That's our negation law, I believe. And then P and T should be equal to P. And that's the identity law, right guys? Okay. So, like I said, I think that's one of the harder problems on the examination to make, just because, you know, it's not numerically based. So, does that help out a little bit?
that's right.
Okay, and there's not too many parentheses in that for your license. Should I shine your shoes, sir? Should I wash your car? Should I give you a back rub, sir? Anything else I can help you with? I'm just completely messing with you. Okay. And then you wanted me to do one of the rules of inference problems, correct me?
Yes.
Okay, will do. Did you have one on the exam review, or maybe somebody has an exam review that I can pull
The
up?
one on the exam review is one of the same as one over in class.
Gotcha. Okay, so that wouldn't help too much.
Yeah.
Okay. I'm wondering if there's one on the textbook online that I can pull off that we haven't done before. So let me look at that real quick. So you can write this on the teacher evaluation. Instructor utilizes the textbook. There we go. Once in class, but
Does not know how much more pop.
what are you squawking about? I'm going to make up a special exam just for you. It's going to say Donnie's exam. And the first word of every statement is going to be prove. Everything's going to be prove.
And everyone's gonna say, prove you get a 0.
By the way, did you grade the homeworks?
I did. Yep, I'll give them back.
Okay.
Let me do this, and then I'll give back the assignments.
So you must have done it today because I didn't see anything last night.
What's that? I just posted the grades today.
Oh, okay, good.
I meant to come up here on Saturday, but couldn't do it.
Dedication died on Saturday.
Yeah.
That was me on Sunday. My wife,
Actually-
are you gonna do anything today? I said, no.
Sleep. Yeah, ignore you. Does that count? It's probably not the answer you wanted to hear. Hey, there we go. Finally. Sorry, guys. All right, so, we didn't do one like 44, did we? Boy, that one's ugly. Let's do that one. That looks like fun. Okay, I'll go through it fairly quickly because I do want to make sure we have enough time to. P implies Q, R or S. Not S implies not T. See, I could have given you guys much worse problems. Not Q or S. Not S. Not P or N R. Implies U, W or T. Jeez. This never end. U and W. All right. So, the first, what I always suggest is start with the easiest thing, okay? Guys, oh, how many?
Yeah, 4 and parking.
Sold.
Night.
Sold. How much do shut up. You get your greedy little hands off my table.
Or and B, C-Lot. My recommendation is C-Lot gets you out faster at the end, but.
My recommendation is I'm going to blow a lot of money in my own beer.
Oh, that's the other thing. If you can use 4, use them all. Otherwise, sell the other 2
Oh yeah, I already do that.
for $35, and then you get 2 racks.
Yes, but I don't want to sit next to some jerk off. So.
That's true.
Okay.
You got to think about who you sell them to, because then
That's
you'll be sitting
true.
next to them.
Okay.
Hey.
Winner, winner.
Yeah.
Thank you.
Have a blast.
I will.
I know.
Lucky enough
And bring home a victory, or else don't bother coming in tomorrow.
Yes, ma'am.
Yes.
All right. Wow. No. Sorry. Okay. Start with the easiest thing.
R and S, not S.
Yeah, so I think the easiest thing to do is start with not Q and or S. We have not S. So we could use this one. Okay.
Then eliminations.
And by elimination,
No.
if you don't have one of them, you have to have the other one. So that would have to be not Q by
Not
elimination.
Q.
Okay.
Then you have to do R and S also.
Okay. Yeah, you can also use this one as well. So I don't want you guys thinking that you can't reuse the premises. Okay. So notice we have R or S. We have not S. So we have R or S. We have not S. Therefore, it has
R.
to be R.
Elimination.
Yeah. Okay, so, and notice guys that now we can use these, okay? So basically the way I think about it is, you just get rid of one of these, and you're just replacing it with something new, okay? So is that okay so far with those two?
What was that last thing you said? I'm sorry.
Oh sure, like every time you use like a premise here, you're actually creating a new premise over here. So these are things that what I circled, those are things you want to use again, okay, at some point, okay? All right. So the next thing is I look for something with either a Q or an R in it. And guys, if you notice right here, you have a P implies Q. You can use this, you can use that not Q there, okay? You just have to find something that has P implies Q and not Q in it as well, which would be modus tollens, right?
Or else you can do that. Not S implies not T,
No,
not
we'll get
S.
there. That's fine.
Yeah.
We could. All right. So there's lots of things we could use. Okay. There's no specific order that you have to use it in. Okay. So third thing, we have P implies Q. We have not Q.
So not T.
Yeah. And that's just going to lead us to not P, and that's by your modus tollens. Okay. So.
Can you write M? Yeah, it's equal with that, right? MT, MP, like this.
What's that one more time?
In the exam, if you write MT or MP,
That's
yes.
fine. I know what that means. Okay. So now we're done with this guy. Wherever he went. You already know that we have dot S from right here. So you could use that once again right here with the S, the not S and T. Okay. So for a fourth step, you have not S implies not T. You have not S. Therefore, that's not T. And that's by modus ponens. Okay. So, boy, this one uses the not S like every step. So we got rid of this guy. And again, I'm going to circle. Notice what I'm doing is I'm circling the conclusions because that's what I want to use again at some point. Okay. So every time you get these, that's where you want to go to. Go ahead.
I don't have the paper in front of me, but I think we need to have the not P and the R actually make a not P.
Oh, yeah, absolutely. Because notice that we have a statement that has not P and R, so we have to conjoin those and use a conjunction to get to the U.
So that was that one, it wasn't the not P or R, it's not
Correct. You can't use or, but you can use and to join those together. So from step 2, we have R. This would be step 5. And then we also have not P from step 3. Therefore, we have R and not P. Or, I guess I should put them in the order that they're given, not P and R. Okay. So what I'm doing is I'm just saying I found this to be true, I found this to be true, so they're both true. Does that make sense to you?
Yeah.
Okay. So I'm just going to flip the order of these. And the reason I do that is because I need this guy right here. Okay. So now I can use a modus ponens right here. So I have not P and R implies U.
Not P and R.
Yep, I have not P and R. Therefore, I have U. Okay, and that's by modus ponens. And the good news is, isn't U one of the things that I need for the conclusion? Because if you look at that, so I'm halfway done with what I need, okay? The only other thing that might be helpful is if I had a W, okay? So, and the good news is, right here you have W or T. Remember from before, in step 4 we had not T, that eliminates that. So for step 7, we would have W or T. We have W, or we have not T.
So therefore W.
So therefore, we have to have W.
Elimination.
By elimination again. Okay. In fact, we've used elimination twice before. Okay. Does that make sense so far, ma'am? Did I lose you anywhere?
Yeah,
So this was given to us in the original, right?
right.
We used not T from step 4. So you either have W or T. You don't have T, so by default you have to be left with W. And that's the elimination. Okay?
What is 5 then? Is it examiner then? Or is it this?
Oh, this is, I'm sorry, that would be helpful. This is conjunction. I'm sorry about that. Okay? All right, and then the last thing that we want to do is we want to verify this conclusion. Okay? Well, notice that we have U from step 6. We have W from step 7. Therefore, we have U and W. And that's the end of this. Okay? So for step 8, we have U, we have W. Therefore, U and W. And that's, again, by conjunction. Now, that one's probably harder than what I've asked you in the examination. Okay? But at least it's another example for you. So I don't know if that helped or hurt you any, because I might have scared you some.
And then that helped, but on the exam, we also have to put which step we got.
Yeah, like you'd probably have to go back, and I just abbreviated it, but
Okay.
if you look at the solutions to the homework, I think that might help. Okay, all right.
Oh, I mean, you just said look at the solution to the homework, but did you mean when we reuse a letter, we have to say which